Good morning. So this upcoming question is for the students preparing for AP Physics in America and students who are preparing for JEE mains in India. Now the key characteristic of this upcoming question is your knowledge of trigonometry. Okay, and you will see why is it important to understand trigonometry to be able to solve questions on physics. So the topic I'm going to bring up is the topic of kinematics, and you will see that the nature of the question, unless you have strong hold on trigonometry, it will be difficult to solve this. So let's start with the question and see the importance of trigonometry in this question. Thank you very much. So as you can see on the screen, this question is from Resnick and Halliday. Question number 86. Let's read the question first and analyze it. So there is a radar station which is detecting an airplane approaching directly from the east. So you can see from the eastern side an airplane is coming, and there is a radar which is continuously detecting the airplane. At first the observation is at a distance of 360 meters from the station. So this distance is given to be 360 and the angle is given to be 40 degrees above the horizon. The airplane is tracked through an angular change of 123 degrees. So this angle is 123 degrees. Just for your information, the radar keeps on moving to detect the plane, right? It moves with the plane, and the distance when you move through this angular distance of 123 is 792. So this is D2 is 790. The question is, find the magnitude and direction of airplane's displacement during this period. So you can see the word displacement mentioned. You can see the magnitude. So they're referring to some kind of a vector of displacement, asking us to calculate both the direction of the airplane's displacement and also the the magnitude of the displacement. Okay, and seemingly the plane has not got elevated. The height of the plane remains constant throughout the motion. Okay, now if you notice, there is no speed given in the question, right? Generally when you do a kinematics question, there is a speed, there is time and all stuff like that. Nothing is given. So if let me show you the solution and emphasize the importance of the knowledge of trigonometry to be able to solve these questions. So if I draw this diagram, it looks like this. You are talking about a situation like this, the same height, and this is your displacement, right? This is the displacement being asked. Okay, now this is given to be 790. This is given to be 360. The angle between them is given to be 123 degree. So if you notice, this is more of a triangle problem, where if you are given two sides of a triangle and the angle between them, you are expected to find the third side. How do you do this? The way to solve this is use the law of cosine. Okay, what does the law of cosine tell you? If this is A, this is B, this is C, the length of these sides is A, B, C, and the angle opposite to C is capital C, then C square is equal to A square plus B square minus 2AB cosine of C. Okay, this is the way you need to approach this. So your knowledge of triangle is very important in this case. Speed is equal to distance upon time doesn't help. There is no other way but to use a trigonometry trick to solve this. So let's say C square is equal to 790 square plus 360 square minus 2 into 790 into 360. And what is this angle? The angle between them, this angle, right, is cos of 123. This will fetch you what? This will fetch you the magnitude of the displacement. Okay, you can solve 79 into 79. 9 nines are 81, 9 sevens are 63, and 8 is 71. 7 nines are 63, 7 sevens are 49, and 6 is 55. 1 4 12. So this is 624100, and 36 into 36. 6 6s are 36, 6 3s are 18, 3 6s are 18, 3 3s are 9 10, 6 9 2 1 2 9 6. So 129600 minus, you can calculate, you can see the sine table for cos of 123. Calculate all of this, you will get the answer. So that's your first part. What is the magnitude of the displacement of the airplane? Displacement is a direct distance which you calculate. Now the second part of the question is, what is the direction of the airplane's displacement during this period? Okay, now this is, where is the direction is the question, right? So if I join these two points, you know, which is this, what will constitute the direction of the airplane's displacement during this period? Let's think through this. You know, my assumption initially was the height is remaining same throughout, and therefore the angle which it makes with the x-axis is 0 degrees, but I may be wrong in that case. You know, the direction of the displacement is the angle of the displacement vector. So if you have a body moving from A to B, this is the magnitude of the displacement, but the vector is then measured from the x-axis, right? So we also need to measure the vector, which we will get C, this vector, right? What is the angle this makes with the x-axis? So this is D1 and this is 2. Find the direction of the, so if you notice, this angle 40 degree is also available to us, right? This is 40 degree. We have not put this to any good use, by the way. Okay, now let's put it to some good use. Now we know what is the value of D1, right? D1, and we know the angle it makes with the horizontals. This height is then equal to how much? This is hypotenuse. Okay, so this is your hypotenuse. This is 40 degrees. So how much is this? This is 360 into sine of 40 degrees, right? We know the height. Let's go on the other side. So this is 123. This is 40. What is a balance angle? The balance angle will be 180 minus 40 minus 123 is equal to 140 minus 123 is equal to 17 degrees. So this is 17 degrees we are referring to. This is another 790. Using again the knowledge of trigonometry, we would know that how much is this. So this is 790 sine of 17 degrees, right? So which means the height is different in both the places. This height is coming out to be 360 sine 40, 360 sine 40 degrees, and this height is coming out to be 790 into sine 17 degrees. So I haven't written the values of sine 17 and 790 and 360 and sine 40. Let me just write the values of these two, sine 40 and sine 17, and then solve it. So my initial assumption that the height is same probably will turn out to be wrong. Okay, let me just find out the values and from the sine table and write the values first before we proceed with the further working of the question. Okay, what I've done is I've written the values of sine of 40 and sine of 17 degrees. Then I've multiplied this 790 into sine of 17 as 229 meters. So this height comes out to be 229 meters. And on the other side, when the plane was observed, the height is coming out to be 360 into sine 40, which is 268 meters. So you have a situation where actually the plane lost elevation. It actually has come like this. Okay, on one side the height is 268, and on the other side the height is 229 meters. 229 meters. So this is the situation. So if I were to draw a straight line from this place, this is my straight line, this is the gap in the height, right? And we have to find the angle of this vector, right? This is the displacement, which we already calculated as c. So we know the displacement. Okay, we know this also. Now this is 268 minus 229. So 268 minus 229 is 939 meters. So this is 39 meters, this part. And this is how much? C. Okay, we have not done a calculation of C, but whatever it comes out to be, okay, C. And we have to find the angle which this vector makes with the, okay, so first let's find this angle. Okay, what is the angle? So if the plane has lost on elevation, we know this is a triangle, right? So let's say this is OAB. So this is the first position of the plane, this is the second position of the plane, this is now a hypotenuse, this is a perpendicular. If this angle is theta, for example, then I can write sine theta is equal to 39 meters, which is the loss of elevation, divided by c. C is the displacement, hypotenuse, which we can find using the above formula. Okay, you can do the complete calculation of this whole thing, long one. So you can find this theta also. Okay, and this theta is in this direction. Okay, so you can see this, the angle it is making with this x-axis. So if there is a loss of elevation, okay, so this is your theta, right? So you know that the plane is making angle theta with the x-axis. Really speaking, the angle should be this, right? It should be 180 plus theta, because you always measure a vector. If you're given a vector like this, which is our displacement vector, this is not the angle. If you extend the vector here, the angle actually is this, okay, or it is measured like this, right? So this angle, if you want to use this as an angle, then this angle is with the negative x-axis. If you want to find it with the positive x-axis, then add 180 with it, 180 plus theta. So this whole angle, because this is your positive x-axis, angle is this much. So I hope this made sense. Very important question for people preparing for AP Physics, and you can see the power of trigonometry here. So there is a topic in trigonometry called as triangles. So go and memorize some of the theorems available in the chapter that deals with the triangles. Okay, Law of Cosine was just an example to you. So I'll solve few more questions from Resnick and Halliday for those who are preparing for AP Physics. And the idea is to open your mind so that you can think problems as physics problems, definitely, but the underlying tool is many a times is mathematics. If you notice, the whole Resnick Halliday is based on good understanding of tools of mathematics, such as trigonometry, such as integration, differential calculus and stuff like that. So thank you very much. I hope you enjoyed this video. If you did, please do subscribe to this channel and like this. Thank you.